In this tutorial, you'll learn how to multiply radical expressions. If you're following along in your notes, write this topic in the table of contents with the appropriate page number. Alright, let's get started. The learning objective today is to multiply radical expressions. You'll know you've been successful if you do the following three things. The first is to multiply the coefficients and radicands separately. That means coefficient numbers times other coefficient numbers, and radical numbers times radical numbers. When you're done multiplying, you always need to try and simplify your radical terms. And when you're doing that, you should simplify by looking for perfect squares or pairs of numbers. So pairs would be two factors that match, that are exactly the same, that are multiplied together, like 3 times 3. So that would be a square number, 3 squared, but it's written out as two separate factors, so a pair. You recall when we were adding and subtracting that we talked a lot about like terms and unlike terms. The good news is when you multiply, it doesn't matter. The radicands do not need to match. They do not need to be alike. You can just go ahead and multiply. So let's get started with this question here. The square root of 3 times the square root of 12 can be rewritten with one longer radical bar, and the radicands, 3 and 12, just written as a product underneath. So I take these two radical symbols and I make one larger symbol. And I simply take the math and put it underneath. 3 times 2 is 36, and that's a perfect square. So the answer to this is a nice round 6. Now, they're not all that easy. So let's try one that's a little bit more challenging. Example A, the square root of 5 times the square root of 10. Again, we take those two radical signs and combine them into one larger radical sign. And when we're done, we're looking for perfect squares as factors. So let's take a look. 5 times 10 is 50. The square root of 50 is not a perfect square. But there is a perfect square that can divide evenly into 50, and that's 25. So I can rewrite 5 times 10 as 50, but eventually I'm just going to have to get smaller and use perfect square factors. So the square root of 25 is square rootable, but the square root of 2 is not. So I'm going to break this back up into two separate problems. Square root of 25 and the square root of 2. Square root of 25 is 5, square root of 2 remains the same, and this is your final answer. And that's where you stop. Alright, let's take a look at another one. If I had decided not to multiply 5 times 10 to get 50, I could also have done this, right? Instead of getting bigger just to get smaller, I could have just went smaller to begin with. So 10 can be renamed as 5 times 2. And when you do that, you get a pair of 5s. And that's the same as like a 5 squared, right? 5 times 5 is 5 squared. And when you have a square underneath a square root sign, they cancel each other out. And that's why we get a 5 as our coefficient. Now we don't do this too often, writing this step here. You can, but we don't do it too often because it's not really necessary. As soon as we see this pair of numbers, we typically just say, okay, I have a pair, and when a pair comes out, it remains the same, right? That's different. So when I take the square root of 25, it doesn't come out as a 25. But when I take the square root of a pair, it comes out as itself. So if you're trying to take this shortcut here with the pairs, don't get it confused. Right? You don't square root the pairs, you square root a perfect square. So if you see a pair, it comes out as itself. But if you see a perfect square, it comes out as a root. Nevertheless, the answer here is 5 square roots of 2. Again, try not to go bigger, just to get smaller. Example B, the square root of 3 times the square root of 15 is the square root of 3 times 15. Now, I can certainly write a 45 here, but 45 is not a perfect square. So let's practice renaming 15 with two factors, preferably one that matches something I already have. So 15 can be written as 3 times 5, and there's a pair. Remember what I said about pairs? They come out as themselves. So those 3's are going to turn from radicands into coefficients, a single 3. 3 comes out, but the 5 stays in. The answer is 3 square roots of 5. All right, let's try a third one here. I think you're starting to catch on. Square root of 11 times the square root of 6 is the square root of 11 times 6. Now I can certainly get bigger, but let's just try getting smaller here. 6 can be factored into 3 and 2. But unfortunately, I have no perfect squares and no pairs of numbers. And when that happens, you just have to multiply them all together. So sometimes it is as simple as that. Multiply one times the other and you're done. Square root of 66. All right, this is some beginner multiplying here. I think you're starting to get the hang of it. So let's try 3 that were just like what we just did here. Remember, radicand times radicand, simplify if you can. Pause the video now. All right, let's see how you did. Did you get them right? I hope so. Okay, let's make it a little more challenging for you. Let's put a coefficient in front of the radical sign. Now, if you remember from the beginning in the preview, I said you need to understand that you multiply coefficients times coefficients and radicals times radicals. So coefficient times coefficient and radical times radical. So 3 times 2 and 5 times 10. 3 times 2 is 6, and 5 times 10 is 50. Now, if you'd like, you don't have to bring it all the way up to 50. You can start with initially breaking it down into as many factors as you can. If you find a pair, it comes out as itself. But if there's already a coefficient out there, you've got to multiply it, right? So if you find a pair, you come out as yourself, but you multiply by the coefficient already outside. Anything that's not a pair remains underneath the radical sign. 30 square roots of 2 is your final answer. Let's try that again. 4 square roots of 3 times 3 square roots of 12. 4 times 3 and 3 times 12. 4 times 3 is 12 and 3 times 12 is 36. Now I know I said don't multiply and get bigger, but 36 is a perfect square. So I don't need to factor it down. And 36 is going to come out as its root, right? It's not a pair, it's a perfect square. And when you come out as a perfect square, come out as your square root. And 6 is now a coefficient, 12 is my existing coefficient. I multiply them together, and I have nothing left underneath that radical sign. So this time, we got a whole number. All right, let's take a look at one more. How about a negative coefficient? Negative 2 times 8 and 6 times 15. Negative 16. And 6 times 15, I could certainly do the math there. I believe it's 90. But why not just break that 15 down? And maybe while I'm at it, break down that 6. So 6 is 3 times 2, and 15 is 3 times 5. And they're not next to each other, but they're still a pair. And a pair comes out as itself. And it multiplies by the coefficient already out there. Now this 2 and this 5, they're not a pair and they're not perfect squares, so they remain underneath the radical sign. So the 3 comes out, but the 2 and the 5, they stay behind. So our final answer is negative 48 square roots of 10. Catching on? All right, if I went a little too fast, pause the video, go back, just watch these 3 examples again. Even mute it if you need to. But if you're ready, give these 4 a try on your own. Multiply and simplify. Pause the video now. All right, let's see how you did. Okay. Hopefully you got these 4 right. If you did, you're ready to try your class worksheet. So that concludes our lesson on multiplying. Tomorrow, we'll practice dividing. Great job today.